Everyone, I'm going to tell you about Seismic Survey. My name is Karimova Marzhan and my colleague is Aitzhanov Diar. So let's start with Seismic Survey definition. Seismic survey is a geophysical operation that uses a seismic energy source to generate acoustic wave that propagates through the Earth, are reflected from or refracted along subsurface layers of the Earth and are subsequently recorded. The seismic survey is one form of geophysical survey that aims at measuring the Earth's properties by means of physical principles such as magnetic, electrical, gravitational, thermal, and elastic theories. Seismic wave can be categorized into two major types: body and surface wave. Body wave propagates through the entire body, whereas surface wave travel along the surface of the medium. Seismic body wave include two different types according to the relative direction of disturbance. With respect to direction of propagation, primary and secondary wave. Seismic survey wave also includes several different types, the Leyland wave being one. So, how do seismic survey generate? A seismic source such as sledgehammer is used to generate seismic wave, sent by receivers deployed along a present geometry called receiver array, and then recorded by a digital device called seismograph. Based on typical propagation mechanisms used in seismic survey, seismic waves are grouped primarily into direct, reflected, refracted, and surface wave. Seismic reflection outlines. When a seismic wave encounters a boundary between two materials with different acoustic impedances, some of the energy in the wave will be reflected at the boundary, while some of the energy will be transmitted through the boundary. The amplitude of reflected wave is predicted by multiplying the amplitude of incident wave by seismic reflection coefficient, determined by the impedance contrast between two materials. There are three stages of seismic survey: data acquisition, seismic processing, and seismic interpretation. Let's start with seismic acquisition. It is used to produce a seismic image of the subsurface. A seismic source must be generated and the resulting reflection data recorded by a field crew. In this way, land and marine seismic data is created and recorded all over the world. Second one is seismic processing. Next, the data must be processed, where the raw data is put through the many complex procedures using powerful computers, and finally a seismic section is produced. The last one is seismic interpretation, making sense of the seismic image, identifying and mapping geological structures that can act as oil traps, is the final stage of the seismic process. There are three major types of seismic survey, which is refraction, reflection, and surface wave, depending on the specific type of waves being utilized. First one is refraction survey. Uses refracted wave to deduce velocities of the layered Earth model. So-called first arrival information is used for the analysis. More generalized method based on the turning wave from arbitrary velocity model have also been used in recent days. This is called seismic refraction tomography. Historically, the refraction method has been commonly used to map the depth and velocity of bedrock. Second one is reflection survey method. Reflected wave from the interfaces between materials of significant different elastic properties, density, and seismic velocity are used for this type of survey. More specifically, a special acquisition processing method called the CDP, Common Depth Point Method, is used, and the final product from the survey is a section that depicts a cross-sectional image of the subsurface below the surveyed line. This method was invented and has been used traditionally in exploration for natural resources. And the third one is surface wave survey method. When seismic waves are generated, there is a special type of wave propagating along the free surface, called surface wave, whose penetration depth is wavelength dependent. The longer wavelength influences the deeper portion of the Earth. Because of these properties, surface waves are generally dispersive. meaning different frequencies have different propagation velocities. Two types of survey waves are generally known: Rayland and loud wave. The disturbance vibration direction of the former is merely perpendicular to the surface, whereas it is parallel for the latter. Theoretically, the dispersion property of the surface wave is determined by several elastic properties, including and depth, including density and depth variation of secondary and primary wave velocities. Among these parameters, the depth variation of secondary velocity is the most influencing factor. Because of this, surface waves are often used to deduce secondary velocity properties of near-surface Earth materials, in comparison to using conventional body wave method to achieve similar secondary velocity information. For example, secondary wave refraction, reflection, downhole cross-hole services. The survey wave have several advantages. Field data acquisition is very simple and tolerant because surface waves always take the strongest energy. The data processing procedure is relatively simple and easy even for non-experienced. A large area can be covered with a relatively short time period. Because of all above reasons, it's highly cost-effective and time-efficient. So let's move to difference between refraction and reflection services. In refraction seismic survey, which is it is based on contrast in seismic wave speed, while reflection seismic survey based on contrast in seismic wave impedances. In refraction seismic survey, material property determined wave speed only. In reflection seismic survey, wave speed and wave impedance determined. In refraction seismic survey, only travel time used. In reflection seismic survey, we also use amplitude. In refraction seismic survey, no need to record amplitudes completely, therefore it is relatively cheap instrument. In reflection seismic survey, must record amplitudes correctly, therefore it is very expensive instrument. Refraction seismic survey, source-receiver distance large compared to the investigation depth. In reflection seismic survey, source-receiver distance small compared to investigation depth. There are two types of seismic survey, which is marine and land seismic survey. Marine seismic survey Marine seismic vessels use a combination of air guns, water guns, and other acoustic sources to create the pulse needed to take seismic readings. The water gun is preferable to the air gun because the air gun generates an unwanted secondary pulse after initially being fired, which obscures the waveform that can disturb the proper interpretation of the data. The point is to produce an acoustic vibration that can be read by the geophones and interpreted to reveal the geological features underneath the sea floor. Whatever the acoustic source, the goal is produce seismic pulses that reflect off the boundaries between various layers of rock, all of which will cause the sound wave to react differently. It is important that pulse be emitted in rhythmic repetition as the vessel moves to create detailed plans of mapping. Inland seismic survey tend to be large entities, requiring hundreds of tons of equipment and employing anywhere from a few hundred to a few thousand people, deployed over vast areas for many months. There are a number of options available for a controlled seismic source in a land survey, and particularly common choices are vibroseis and dynamite. Vibroseis is a non-impulsive source that is cheap and efficient but requires flat ground to operate on, making its use more difficult in undeveloped areas. The method comprises one or more heavy, all-terrain vehicles lowering a steel plate onto the ground, which is then vibrated with a specific frequency distribution and amplitude. Dynamite is an impulsive source that is regarded as an ideal geophysical source due to it producing an almost perfect impulse function, but it has obvious environmental drawbacks. Compared to vibroassays, dynamite is also operationally inefficient because each source point needs to be drilled and the dynamite placed in the hole. That's all from Seismic Survey, and thank you for your attention.